So we have the sample exercise. The results of a nationwide aptitude test in mathematics are normally distributed with the mean of 80 and a standard deviation of 15. What are the scores that bound the middle 95% of the distribution? So let me just close this a box so that we'll be guided that this is what we're trying to look for in the problem. So let's try to write the given values here. So since this is a nationwide aptitude test, so the values are the population mean, which is equal to 80, and our population standard deviation, which is our sigma, which is equal to 15. Now, the first step here, first step is to illustrate the curve and locate the area. Okay, illustrate the normal curve and locate or determine the area. Okay, and so let's some adjustments here, and we're going to insert an image of a normal curve. Okay, then we have to take note that since we're trying to locate the area that bound the middle 95% of the distribution, so half of the area is going to be below the mean and the other half is going to be above the mean. So we're looking at this area. Let's we do not know yet, now somewhere there. So both here left and which is below the mean, and the right side of the normal curve, which is going to be above the mean. Now we have to take note that both areas, in this case, both areas have the same value. Have the same value. That's what we have to remember. Okay? Divides the scores that bound the middle 95% of the distribution. So now next is the second step is we have to determine the areas. We have to determine the areas. So second step, so determine the areas. So how do we determine this? It's very important, no? How do we determine this? Let me just make this a little bigger. So how? Let's put a question mark. How? Okay, how do we determine the areas? So we just need to express 95% into probability. So 95%, we are going to convert this into probability, and this is going to be 0.9500, and from here we are going to divide 0.9500 into 2. So if we divide this into 2, 0.9500 divided by 2 this is going to be equal to 0.4750. Okay, we're dividing it into 2 again, because remember, we have to look at what is being asked. What are the scores that bound the middle 95% of the distribution? And as presented in the first step, both areas would have the same value because it's being divided into 2. We're looking at the middle 95% of the distribution. Now, the next step, which is our third step, is to look for the z-score this time. Look or determine, let's just put determine the z-score, the z-score, the, sorry, z-score that corresponds to 0.4750. Okay, so that's our, this is our third step. Again, let's just go back a bit in step number 1, since we have identified already in step 2 the area, which is 0.4750. In step 1, let's just so what you see at the left side of the normal curve, there's going to be the area there is 0.750, this whole area, and also the area above the mean is also 0.4750. Okay, just to clarify it with you. Now let's go back to our third step. Determine the z-score that corresponds to 0.4750. In the z table, it's 1.96. Okay, it's 1.96, which is equal to 0.4750. Okay, can you just check your z table? Now, since both areas are found below and above the mean, so the value of the other z-score is going to be negative 1.96. Okay, so below the mean, this is let me just put it this way, like below the mean, the z-score is negative 1.96, and above the mean is positive 1.96. Okay, now let's proceed to, we're not yet done, let's proceed to the fourth step. Let me just extend this here. Fourth step, our fourth and final step is to determine the scores of the aptitude test in mathematics that bound the middle 95% of the distribution, which corresponds to the z-scores that we have just determined. Okay, since negative 1.96 and positive 1.96. Okay, now using the z-score formula for population data, we have this x is equal to this is z is equal to x minus mean all over sigma. So since we're trying to look for the raw score, let's just isolate x. So to isolate x, we multiply sigma on both sides of the equation. You have here the z-score times sigma is equal to x minus mu, and after which we have to add both sides by mu so that we can totally isolate x on one side of the equation. So z times sigma plus mu and x minus mu plus mu. So this is equal to z times sigma plus mu is equal to x. Okay, this is now our working equation for us to be able to determine the raw score. Now let me just make some adjustments here. So let's write it this way. So divide this into 2. This is, so let me just put it this way. So we have the raw score below the mean, which is we have here the z-score, which is equal to negative 1.96. Let's denote this as x sub 1. Okay, so x sub 1 is equal to our let's have our z-score, so z sub 1 times our sigma plus mu, and the raw score above the mean, let's denote it as x sub 2 is equal to z sub 2, the z-score corresponds to our area above the mean, times sigma plus our mu. So let's just substitute the values here. We have, just write it here. So x sub 1 is equal to our z sub 1, which is negative 1.96, okay, times our sigma, which is 15, plus our mu, which is equal to 80. So here x sub 1 is equal to, let me just check our calculators here. So it will be guided. We have negative 1.96 times 15 plus 80. So we have 50.6. So 50.6, and let's check the raw score above the mean. So x sub 2, sorry. This is x sub 2, just, okay. It's equal to our z sub 2, which is positive 1.96, times our sigma, or population standard deviation, which is 15, plus our mu, which is 80. So here we have, using our calculator, x sub 2 here is equal to 109.4. Now these are our final answers already. So we're here. So we have this, which is below the mean, 50.6, the raw score below the mean, and the raw score above the mean is equal to 109.4. So these are the scores. So let's write our answer and complete thought. So the raw scores are down the middle. So the raw scores that bound, sorry, oh, please bear with my handwriting, that bound the middle 95% of the distribution of the distribution are, so let me just change the font color here, 50.6 and 109.4. Okay, that's our final answer, and congratulations. Thank you so much. That's it.